Okay, so we're going over distance from a point to a line. We've been given these two formulas here. First formula deals with two-dimensional space, and you need the Cartesian form of the line, and you need the point from the line you're trying to solve the distance between. Our A, B, and C refer to our normal and our C value from our line. And there's again A, B. And x naught, y naught is the point you're trying to solve from. In our three-dimensional space, it's a little more complex. There's the point from the line. Okay. M deals with the direction vector of the line, so that's our M value. And Q is some point along the line. So essentially, we have to find vector QP, which is a point along the line that will now connect. We're going to create a vector between Q and P, and then we're going to have our line. And this will help us solve the distance from this point to this line. Think of it like almost like a scalar projection. We have to find a right angle because a right angle is or a perpendicular line is the fastest way to get from a point to a line. Okay? It'll be the shortest distance. So, example 1. They've given us this point, P, at -6 and 4. So we're in two space here. And they want to find the distance from the line, which is written already in Cartesian form. 5x minus 3y plus 15 is equal to 0. Wonderful. Because we're in two space, we know that our distance is equal to a x naught. Make sure, is it plus? Yes. Plus b y naught plus c, the absolute value of that, all divided by the root of a squared and b squared. So because we're finding distance, we're finding a value. We're going to be looking for a specific number, not a coordinate or not a vector going through this. Okay? So the distance, well, luckily we already have our a, which means we're going to plug it in for those two values, our b, which will be plugged in for those two values, and our c. I didn't forget to underline that. And our x naught, which is right there, and our y naught, which is right there. So essentially, this one is pretty much already set up for us. We just have to plug numbers into the equation. So D is equal to A, which is 5, multiplied by x naught, which is -6, plus B, which is, -3. So let's put subtract 3. -3 times y naught, which is 4, plus C, which is 15. That's pretty good. Divided by, our A value is 5, so 5 squared, plus our B value, which is -3 squared. We're left with 30, subtract 12, plus 15. We're looking for the absolute value of it again. Over the root of 25 plus 9, it's 34. Thanks, guys. 34. -30 minus 12, -42, plus 15. 32, 27, -27. Divided by root 34. Now, remember this is the absolute value, okay? Because we've been using a vector, it's given us some direction, whether it's going back, forward, left, right, up, down. So even though we have a -27, I really only need the value of 27 when putting into the calculator. So our distance will not be a negative number. You should never have the distance being -5, -3. It'll be some positive number. And we put it into our calculator. We get 27 divided by root 34 is equal to 4.63. So the distance from the point to the line is 4.63 in this case.